In this episode, we take a look at the PEP ability test practice booklet given to us by the Ministry of Education via the Book Fusion website. That's here. And if you want to do the test after watching the video, a link can be found in the description box below. I have also done a few other videos from this same set of PEP practice books that are here, so you can also find those in the description box below. So once we type in Book Fusion in the browser of our choice, then we come here, we're going to hit libraries, get to libraries, we're going to go to the Ministry of Education and Youth and Information website, their library rather, and we go here we have some of the other books. We have done a few of these already, and then we can go over and we want to do the one on PEP. So let's get this one up. Okay, and here we would click on read and it pulls this one out for us. Loading. All right, so let's click to continue. And of course, it says this paper consists of 10 questions. Always make sure you read all areas of the booklet so that you're comfortable with the information and instructions given. And now we have question 1. Question 1. David's mother gave him $200 to buy some carrots at the Blue Market. She will be using the carrots to make juice for her church barbecue on Friday. At the market, David finds 2 vendors selling carrots. Vendor A has carrots for $40 per kilogram, and vendor B has larger carrots, and these carrots are for $50 per kilogram. Here are the questions. A. From which vendor should David buy carrots? And B. Explain why you have chosen that vendor. All right, so let's do 2 things. Let's bring up our whiteboard. That's 1. And then let's seek to answer these questions here. So we have 2 vendors. So let's see if we can put these vendors here. So let's say we have, okay, let's select our pencil. All right, so we have vendor A and we have vendor B. These are the vendors under consideration. Now he has $200 and we want to find out how many kilograms he will get if he buys carrots from vendor A. So he has $200 here, and the cost per kilogram from vendor A is $40. So let's divide the money that he has by 40. And the same thing for vendor B. He has $200 to spend, but this time around vendor B is charging $50 because the carrots are bigger. Now, let's see how many kilograms he will get if he purchases from vendor A versus how many kilograms he will get if he purchases from vendor B. Let's go with this. So here we go. Let's switch colors here and get red. So we're going to reduce, here we could say 0 cancel 0, which really means 10 into 200 and 10 into 40 would be left with 4 into 20. 4 into itself 1 time and 4 into 25. So he can get 5 kilograms here. On this one, for vendor B, same process. 5 into itself 1 time and 5 into 20 would go 4 times. He gets 4 kilograms here. Okay. Now, the question says that from which vendor should he buy? I think that he should buy from vendor A because he gets 5 kilograms here. and 5 kilograms would be more than 4 kilograms. Even if these are larger in size, they still don't weigh more than 5 kilograms. So David should buy from vendor A because he will get more carrots for his money, right? And more carrots would mean more carrot juice for the barbecue. So that's question 1. Let's go over now to question 2. Question 2, it says study the table below, then use it to help you make your decision. Now, okay, so here is the first part. You are the captain of your school's basketball team. Your coach has asked you to help him to decide which player will be better able to help the team win an important match against the team that is the defending champions. And we need to study the table to help us to make that decision. So we have the player here, we have the points scored, we have match 1, 2, 3, 4, 5, and the total. So we have Natasha. In match 1, Natasha scored 28 points. In match 2, she scored 26 points. In match 3, 19. Match 4, 21. Match 5, 29. With a total of 123 points. Then we have Andreen. Andreen scored 44, then 0, then 31, then 6, then 42, and also scored a total of 123. So I can guess, you know, if both of them scored the same total, how do we make the decision? Question A, which player will better improve the team's chances of winning? And explain why you have chosen that player. All right, so let's get back to the whiteboard and let's make some space here and start talking about this one. Now, we have Natasha, and one of the things that jumps out at me with this question, very important point here, is the fact that we need to understand averages. Okay, let's see. For Natasha, let's work out an average. Natasha scores 28 points, then 26 points, then 19 points, then 21 points, 29 points. Okay, if we were to add all of these up, we would get the 123 that they were talking about. Let's see if this is true. 9 and 1 would be 10, 10 and 9, 19, 19 and 6 would be 25, 25, and 8 would give us 33. If we have 33, we write 3 and carry 3. Then we could say 2 and 2, 4, 4 and 2, 6, 6 and 1, 7, 7 and 2 would be 9, 9 and 2, 11. I'm missing something. I carried 2 when I was supposed to carry 3. Because remember, we said that we were going to get what? 123. All right, so let's remove that one. And here we were supposed to carry 2, but we were supposed to carry 3, but we actually carried 2. So again, 3 and 2, 5, 5 and 2, 7, 7 and 1, 8, 8 and 2, 10 and 2, 12. So we got our 123. All right, this we know from the table already. For Andreen has 44, 0, 31, 6. Hold on, let's get our 6 right. 6 and 42. Let's add these. So 2 and 6 would be 8. 8 and 1, 9. 9 and 4, 13. We write 3 and carry 1. 1 and 4, 5. 5 and 3, 8. 8 and 4 would give us 12. Pardon me. So both of them have 123. We know this from the table already. What's the average score that each of them would have? In sports, they like to talk about what's the person's average. Now, we already know that with the totals being the same, they will have the same average. So we just went through all of this to show we cannot use the average to make the distinction. Let's look at the average. 123 divided by the number of games that they played. 1, 2, 3, 4, 5 games each. So 5 into 12 would go 2 times. 2 times 5, that would be 10. Let's subtract. We have 2 left. Let's bring down 3. 5 into 20, that's 4. 4 5s. 5 into 23 would go 4 times. 4 5s, 20. We have 3. Remainder 5 can't go into 3. Let's add our decimal point and add 0 to continue. And 5 into 30 goes 6 times. 6 5s would be 30. So the average here would be 24.6. If we round it up, we call this the average being 25 points per game for both of them. We know all of this already. Just looking at the table, we would have been able to see that if the total is 123 for both, the sum of the scores is the same, therefore the average will be the same. So we can't use average to make the distinction. What are we going to look at then? Let's go back to our table. Let's go back to our table here. And in this case, what we would look at the fact that Natasha always scores in double digits. 28, 26, 19, 21, 29. So even though she has the same average score, about 25 points per game, as Andreen, let's look at the difference. 44, 0. 31, 6. Then 42. This person has high scores in some instances, but this one, Natasha, is more consistent. All right. So I would say for A, which player is the better player to choose? We would have to choose Natasha. Why we would have to choose Natasha? Because she's more consistent. She has scores in the double digits for each game versus Andreen, which has the lowest score, which is 0 of the two, right? And does not always score in double digits. Let's go with question 3. Question 3. In a bag, there is an equal number of red, blue, and yellow marbles. How many marbles could this be? The answer here is 16 or 29 or 37 or 42. Now, let's jump back to our whiteboard. And let's look at our options. Our options are 16. And it says that what the number could be if it is that what happens. If it is that there's an equal number. So equal number for 3 containers, meaning what we're dividing by 3. 16 divided by 3. 3 into 3 5s would be 15. 15 remainder 1. So this couldn't be equal because we have a fraction left over. Let's look at the next number. The next number was 29. 29 divided by 3. 3, let's go 3 nines would give us 27. So this is 9, 27, and remainder 2. So that's 2/3. That wouldn't work because we still have a fraction left there. What about 37? Let's see with 37. Let's put 37 here. Divide this by 3. 3 12s could give us 36. 36 from 37, we have remainder 1/3. What about 42? 3 into 4, that would go 1 whole time, remainder 1, and 3 into the 12, 14. Okay, so this one goes in an equal number of times. Now, the concept here that is important for you to understand is the concept of divisibility rules. Divisibility rules. Before I do that, let's look at the same numbers. We looked at them here fractionally. Let's just make sure that we're looking at them too. If we were going to divide the same number, let's set out our thing here and say 3 into 16, and this would be 5, and 3 5s would be 15, and we subtract and we have 1, and then this would be really what? 5, the whole number here, 5 whole times. Remainder becomes our what? Numerator, and then our divisor becomes our denominator. Seeing that for the first one. Then for our 29, let's just go so we can represent them in more than one ways. 3 into the 29 goes 7. Not 7, goes 9 times. Let's correct that. 3 9s would give us 27. So we'd have the 27 here. When we subtract, we get 2. And this would be equal to 9 2/3. Okay? So we have that concept in our head. But divisibility rules now. To our divisibility rules. So we had 16. We had 29. Fix up the 9 here. Good. 29. We had 37. We had 42. Now, the divisibility rule for 3, which is what we want to apply in this case, says that the sum of the digits should be equal to a multiple of 3. Okay? Or 3 would be a factor of that number. So what would 1 and 6, if we were to add the digits 1 and 6, we would get 7. Now 3 can't go into 7 without leaving remainder. So we already know that this couldn't work. So I did not have to do all of this division up here to find out whether it could work. If I know the divisibility rules, it would save me all of that work. Let's go to 29. 2 and 9 would make 11. So again, this number could not work. Let's go with 3 and 7. That makes 10. Now 3 can't go into 10 without leaving remainder. So this number could not work. But 4 and 2 would make 6. Now 3 can go into 6 without leaving a remainder. Therefore, 42 would be the answer. Now, why did I do this last? Some people at this point only know how to reason it out by, doing the division, whether you are going to look at it from a fractional point of view, or you're going to look at it from a long division point of view, remembering the little thing here that every dog must swim back. First, we estimate, then we divide, we multiply, we subtract, and bring down. Okay, about how many times, estimating, about how many times could 3 go into 29? I know that 3 7s 21, so 3 could go more than that. 3 8s 20, yes, 24, and then 3 9, 27. We estimate, then we do our division, then we say 9 times 3, we get our multiplication, then we do our subtraction. Do we have anything to bring down? And we continue like that in that cycle until we are done. Okay, so those are some division facts. However, the key point, the key concept is the divisibility rules. Now, I have done a video on divisibility rules, so if you want to know more about that, you can check in the description box below. We move on to number 4. Let's go to 4. Okay, 4. Now, number 4 says it takes approximately 90 seconds for the average person to brush his or her teeth. All right. If the person brushes their teeth twice daily, approximately how much time does one person spend brushing their teeth in a year, one whole year? That's an interesting question. Is it an hour for the whole year? Is it a day? Is it a week? Is it a month? All right, let's go. What do we need to do? Let's go again. It takes approximately 90 seconds for the average person to brush their teeth. If they do it twice per day, how long would they take to do this in a year? Back to the whiteboard. All right, let's make some space. Let's go down. So what do we know? 90 seconds 2 times a day. So let's say 90 times 2. 90 times 2 would give me 180 seconds. And how many minutes would that be? 180 divided by 60 seconds. Let's divide both numerator and denominator by 10. Then we could say 6 into itself 1 time and 6 into 18, 3. So 3 minutes. All right. So on average, the average here would be 3 minutes per day. 3 minutes per day, 365 days in a year. Hold on, let's see the total amount of time it would take the person then. So 365 days in a year, multiply that by 3. And we said 3 5s would be 15. Let's write 5 and carry 1. 3 6s 18. 18 and 1 would be 19. Let's carry 1. 3 3 is 9 and 1 would give us 10. So it takes 1,095 minutes in a year. Then if it takes 1,095 minutes, can we represent this in hours? What would we need to do? We would say our 1,095, we could divide this by 60. Okay, we could divide this by 60. Now, let's see. What number can we find that could go into both of these? Now, I know divisibility rule again. 5 could go into this and 5 could go into this. Why? Because numbers that end with 0 and 5, 5 can go into them. So 5 could go into 60 12 whole times. 5 could go into my 10 2 times here. 5 into the 9 would go 1 time, remainder 4. And 5 into 45 would go 9 times. So let me tell you what we have now. We have 219 over 12. All right, now 12 into 2, 19 into 21. That could go 1 time. Yes, goes 1 whole time. And how many things would be left afterwards? So if we had 12, 12 goes in there 1 whole time. And let's see. So if we wanted to put this down one side, we could do that. And we take out our 12. All right, and we have 11. Oh, so this would leave me with 9. Okay, so 9 would be left here. So this goes in here 1 time, and I have 9 left. So we have 99 there. 12 into 99. 12. Let's think about our 12 times table. And we said 12 eighths. 12 eighths and 96. Okay, so 8 can go in this 8 times. So this is 18 whole times. Hold on, let's fix this. But we have some remainder, you know, because with the 18, hold on a second. Let's fix this. All right, so we need to undo this. Hang on. All right, good. So this is where we are now. So we said it could, when we take the 12 out of the 21, we have 9 left. All right. So 12 into 99 goes 8 times. And that would be 96, and then we'd have 3 left. So we have 18 and 3 twelfths, right? That's what would be left. And we can reduce this fractional component here because 3 could go into itself 1 time and 3 could go into 12 4. So we could get what? 18 and a quarter hours. Now 18 and a quarter hours. 18 and a quarter hours. Let's go and see what our question here says. Let's go back and see which one of them is closest to that. 18 and a quarter, 24 hours in a day, and they ask us approximately how much time. 18 and a quarter hours, and if it take 24 hours to make one day, it can't be A, because 18 is just 1 hour. Okay, 18 is closer to the 24 hours, but a week is made up of 7 days, and a month is made up of 4 weeks. So our 18 hours is closest to B, which would be 1 day. All right, so the key concept here is estimation, and we have to look at time. All right, so again, we started off by saying 90 seconds, we multiply that by 2 because they do it morning and evening, right? And then we say, let's figure out what this would be in terms of minutes. 180, so the 90 times 2 would give us 180. 180 divided by 60, that would be the 60 seconds make a minute. We end up with 3 minutes. And then we multiply that 3 now with 365 days. We get 1,095. We divided that by 60. And we got 219 there. Okay. We divided that by 12, yes, because we were reducing. We got 18 hours. 18 hours and a quarter, 18 and a quarter hours. So that is closest to 1 day. Now for question 5. Question 5 says there are 5 teams in a basketball competition. Each team must play each of the other teams once. How many games will each team play? Let's go to the whiteboard with this one. So we have 5 teams. So we have team 1. Let's get our color here. So we have team 1, team 2, team 3, team 4, and team 5. Now, team 1, so it will be 1 versus, they can't play by themselves, so it must be versus team 2. Then 1 versus 3, 1 versus 4, and team 1 versus 5. All right. Then team 2 can't play them by themselves. So we have team 2 would have played 1. So 1, no, this would be 2 versus team 1. Okay. Team 2 versus 3. 2 versus 4. And 2 versus 5. All right. Then we have 2. No, this is not 2. Let's start with 3. All right. So this is for team 3. So team 3 has to play team 1. 3 versus 2. 3 versus 4. 3 versus 5. 4 would have to do the same thing, so it would be 4 versus 1, 4 versus 2, 4 versus 3, 4 versus 5. For team 5, they're going to play versus team 1. They play versus team 2. 5 versus 3. And 5 versus 4. How many matches? 1, 2, 3, 4. So 4 here. How many matches? 1, 2, 3, 4. 4 matches there, or 4 games. 1, 2, 3, 4. Same thing for this team. 1, 2, 3, 4. That's all right. 1, 2, 4. So let's pay attention to what they asked us for. Let's go back to the question. The question here says, how many games will each team play? A lot of times when we see this question, and we see our answer here being 4, right? So that's B. Each team will play 4 times, okay? And we could common sense it out by saying, if there are 5 teams and we need to play each team once, and we can't play against ourselves, then you take that, 5 teams, take away the 1, and you get 4, okay? However, a lot of times when we see questions like this, we have to pay attention. They usually ask for how many total matches are in the competition. Let's just pretend that this was that type of question, so we could see how we would solve something like that. All right, so let's go back. So for that setup, we would have to think of it now in terms of team 1, team 2, team 3, team 4, team 5, and we would have 1 versus 2, 1 versus 3, 1 versus 4, 1 versus 5. Okay? Now 2 would have played 1 already, so it would be 2 versus 3, because 1 and 2 play already. Okay? So it will be 2 versus 4, 2 versus 5. Okay? Then 3 has played here already, and 3 has played here already. So this would be 3 versus, let's go 3 versus 4, and 3 versus 5. All right. Then 4 versus what? 4 versus 5. Nothing there. So let's go with this and see how many matches or games are in the competition on a whole. Okay. And why we don't have anything here is because 5 plays here 1 time, 2 times, 3 times, 4 times. Remember, we had seen from before, let's go back up, that each of them would play 4 times. Okay. So let's look at the total number of games in the competition. So 1, 2, 3, 4. Okay, so 4 is shown there. 1, 2, 3. 3 would be shown here. 1, 2. 2 would be shown here. And this would be 1. Now, if we add these, 4 and 3, 7. 7 and 2, 9. 9 and 1, 10. So there are 10 games that would be played in the total competition. Each team would be asked to play a total of 4 games. Let's go with question 6. Question 6 says, if one droplet of water falls every 20 seconds, how many droplets of water would have fallen from a pipe in 5 minutes? Okay, and let's go with this. Would it be 3, 5, 15, or 300 droplets of water? Back to the trusty whiteboard. Now this one is a ratio type item, in that we have here on one side we have droplets, okay, and then on the other side we have time in some amount of seconds. So it says 1 droplet to every 20 seconds. Then they say 5 minutes. So over this side is the time side, and we have 5 minutes. But 5 minutes and we have seconds. So we need to change our 5 minutes to seconds. Now, 5 minutes, if there are 60 seconds in 1 minute, we multiply this by 5, and then we would have here 0, 6, 5, 30. So this would be 300. So our 5 minutes is really 300 seconds. So we're keeping the units the same here. So we had to convert our minutes to seconds, and we get that there. Now we have some unknown droplet that we're trying to find. And for this, we could simply what? Cross multiply to find this. So let's stick with this. So numerator names the side. 1 times the 300 would have 300 on this side, and 20 times x, this would give us 20x. To get, let's make some space. To get this down to x being by itself, this is 20 times x. To get x by itself, we need to divide by 20. If we divide the right-hand side of the equation by 20, we'd also need to divide the left-hand side by 20 as well. So 20 will cancel 20 there, leaving us with x on the right-hand side. Let's go here now. And we could simply say 10 into 300 and 10 into 20. 0 cancels 0. And then we're left with now 2 into 30. 2 into itself 1 time, and 2 into 30, 15. So 15 is the answer that we would get here. All right. So 15. Let's go back to our question and let's see if we have 15 there. So yes, we have 15 as our option there. How many? If 1 droplet of water falls every 20 seconds, in 5 minutes, we should have 15 droplets of water. Let's go to question 7. Question 7. For every classwork given, a teacher gives 2 stars if a student gets 90%, right? 90%. And 90% and above, and 1 star if the student gets 80 to 89. And a student got 4 classwork and earned a total of 5 stars. Which of the following could represent his score? Let's read this again. So for every classwork given, a teacher gives 2 stars if, so here's the condition, if the student gets 90 and above. They get a star if the student gets 80 to 89. Now here we have a student got 4 classworks and earned a total of 5 stars. Which of the following sets of scores could represent that particular student? All right, so let's go over to the whiteboard and we need to set this out. So for A, option A, they said 85, 87, 90, 60. For B, they said 90, 95, 60, and 85. For C, 100, 100, 95, 62. And for D, it would have been 62, 42, 85, and 100. Let's change colors here quickly and let's see what they have here. So they get 2 stars for 90. So anywhere we see 90, let's put 2 stars. 1, 2, 90, and above 1, 2, 1, 2, 90, 1, 2, 1, 2, 1, 2, 1, 2. Okay, all of those. All right, let's go now. Let's go back and let's change color. And we're looking for those 80s now. So 80 to 89 must get 1 star. So 1 star here, 1 star here, 1 star here. Can't give any 60s. No star there. Okay, 1 here. So what we can do now that we have fulfilled all the conditions as expressed in the setup, we can go now and check to see which one would have given the student with 5 stars. All right, so 5 stars, yes. It says a student got 4 classwork and earned a total of 5 stars. Which of the following? Good. So here we go now. So this is 1 star, 2, 3, and 4. So this person has 4 stars. Let's see. We have 1, 2, 3, 4, and 5. Okay. So this has 5 stars. So we can look at this one. Let's check the others. This has 1, 2, 3, 4, 5, and 6. Not this one. And this one only has 3. All right. So our answer should be B. Okay. Our answer should be B. And why B? Hold on. Let's see if we can make this neater and cover everything here better. So they got 2 stars for the 90, 2 stars for the 95, 1 star for the 85, giving us a total of 5 stars. So the key concept here, just eliminate, fulfill the conditions, take out what we know cannot be the answer, and we work our way down until we get our answer. Let's go to question 8. Question 8. Paul, who is 54 years old, is 3 times older than his son Daniel. Daniel is 2 years older than his sister Leah. How old is Leah? Hold on, let's read this again to make sure we understand it. So Paul is 54. Then he's 3 times older than his son. And the son is Daniel, and Daniel is 2 years older than Leah, which is the sister. How old is Leah? All right, I think that we can do this one. Let's go to whiteboard now, and let's start off with Paul. So Paul, let's swap colors. Paul is 54. Daniel is going to be whatever 54 is divided by 3, because he's 3 times older. So 54 divided by 3. All right. And then whatever this is equal to, we're going to take away 2 from that to get Leah's age. All right. So 3 into itself, 1 time 3 into 5 goes 1 time remainder 2. 3 into 24 goes 8. So this is actually 18. So Leah is going to be equal to the 18 minus the 2. So Leah's age should be 16. Let's go. So again, Paul is 54. Daniel will be 3 times, he's 3 times older than Daniel. So whatever Daniel is, that's 18. And we multiply it by 3 to get the father's age. 8 3s is 24. Write down 4 and carry 2. 3 1s, 3 and 2. So we get the 54 there. So that's good. And if he is 18 and he is 2 years older, so it would be 18, and we take off 2 to get to her age, right? So this would be 16. All right, cool. Let's go back to our question and see which option we would select for that one. All right. Okay, so we have 16, 18, 20, and 49. Our option there would be 16. Okay, so this is question 8. Let's go to question 9. All right, question 9. School A and B each have 650 students. The diagram below shows the distribution of male and females in the two schools. So here we have school A, we have school B. So it says an equal number of male and female students, but school A, and they have the color code here. So the blue represents the males, and then the other color would represent, I'm not sure if we can call this red, but let me call it red. This would be the females. So this is not quite down the middle. If it was dead in the middle, it goes over a little on this side. If we were to continue this line, imaginary line, it's a little bit more than half. Okay? So in school A, we have more females than males. All right, let's go with what is said here for 9. It says the number of males at the school in school A and the number and school B are equal. No, couldn't be equal because we have less over here. And in the diagram that would be over here, it would be cut straight down the middle. So that one wouldn't be true. Okay. The number of males in school B is less than the number of males in school A. Number of males in school B over this side, if the diagram it would actually be more, because for this one they'd come over and meet halfway. So that would not be true. The number of females in student A is more than the number of females more than the number of males in school B. Yes, this one would be true. Why? Because the females, this color, I'm going to call it red, goes over, because if we were to draw a straight line continuing down here, it goes over. So the females over here would be more than school B, where you have a 50-50 split. All right, so that's why we would select C. Okay, okay. All right, let's go with number 10. Number 10 simply says, we have a question 10 here. Slow is to fast as young is to aged, history, old, years. This is an analogy, and we look at the pattern here. We see slow, fast. We know that these are opposites, so let's look for the opposite of young, and it would be old. All right, so that brings us to the end of our little quiz here. I want to thank you for watching all the way to the end. Remember that practice makes perfect, and proper preparation prevents poor performance. All right. There are some other videos in the series. Now you can go to the description box, look for those other videos that are in the series, and take the time, do this quiz over again, go to the link, go work it on your own, and see if you have gotten those answers as well. Leave your comments in the description box. Take care, and I'll see you in the next episode.